In this example, we're going to determine the direction of the current for these cases where we have a magnetic field that's actually created by the current in this wire. So in this example, we have current traveling to the left. So let's first figure out the magnetic field due to that. If we point our thumb in the direction that the current's going, so to the left, our fingers curl around and make a circle around that current carrying wire. And on this side, it's going into the page. So we're going to have a magnetic field that's into the page here. And on this side, it's coming out of the page here. So it's circling around this wire. And so thinking about this loop of wire here, it has a magnetic field going through it. And it wouldn't create any current or it wouldn't create a current in there if this current wasn't increasing. The important thing here is that the current is increasing. So if the current is increasing, that means that I'm changing my magnetic field. This magnetic field is also increasing. So this coil of wire sees an increasing magnetic field into the page, and it doesn't like that. It wants to have a constant magnetic field. So it's going to create some magnetic field out of the page. And in order to do that, to create that magnetic field out of the page to balance out the new increasing B field, it is going to create a current going counterclockwise, right? So how do I figure that out? Well, the magnetic field it wants to create is out of the page, represented by the dots. And so then my thumb is pointing out of the page, and my fingers are curling around this loop. And so that means it's going this way. It's going counterclockwise. So we're saying counterclockwise. In this example, I have my current going this way. And so if current is flowing through the wire, it's creating a magnetic field. And here it's going to be coming out of the page, circling around that wire. And on this side, it's going to be going into the page. So this loop is going to see that magnetic field and see that it's decreasing. And so it always wants to correct that, and it doesn't like that it's decreasing. So it wants to create its own magnetic field. So it's going to create some magnetic field the same out of the page. And so in order to create magnetic field out of the page, it's got to create a current in the loop going clockwise. This one, the current is constant. So let's figure out the magnetic field. So the magnetic field on this side is out. So we're going to do dots. And on this side, it's going to go into the page. So it's going to be going this way into the page, my magnetic field. But the most important thing here is that I is a constant. So even though there's magnetic flux going through this loop, through the hole in the loop, it doesn't change. So that says that no current's going to be created because there's no changing flux. There's no B field coming in and out of the page that's increasing or decreasing. So we're going to say 0. All right, and finally on this one, we have current going up. So that's going to create a magnetic field coming out of the page on this side and into the page on this side. And it says it's increasing. So this loop wants to have what it had before, and it's going to has to create a magnetic field coming out of the page to offset the new magnetic flux going into the page. So to create a magnetic field out of the page, my current, so my thumb is going to point towards me to represent the magnetic field, and then my fingers are going to represent the current, and they're going to curl around counterclockwise. And now let's look at this example. We have this loop of wire. So it's a closed loop just in a rectangular shape, and it's being pushed into the magnetic field. So it's being pushed this way. So since it's being pushed this way, more magnetic flux. Right now there's 2, but as it pushes it would grab another one, 3, or push it some more and it would grab 4. So that means the magnetic flux coming through this wire is increasing. So the wire is going to create a current to create some magnetic field out of the page to block off or to counteract that increase in magnetic field. So if I want to calculate the current, I point my thumb towards me, my fingers curl around, and so I need the current to go in the counterclockwise direction. let's just double check. We'll do a quick summary here. So our first one was counterclockwise. So we have counterclockwise, clockwise, 0, and counterclockwise. So let's check counterclockwise, clockwise, 0, and counterclockwise. And then the last one is counterclockwise.